Hi students, in this lecture I am going to discuss previous year's IIT questions. Let us see first one. The region between x equal to 0 and x equal to L is a field with uniform steady magnetic field given minus B naught K cap. A particle of mass M, positive charge Q and velocity V naught I cap travels along x-axis and enters the region of magnetic field. Neglect gravity throughout the question. Find the value of L if the particle emerges from the region of magnetic field with its final velocity at an angle 30 degrees to its initial velocity. That's the first question. And coming to second one, find the final velocity of the particle and the time spent by it in the magnetic field if the magnetic field now expands up to 2.1 L. Let us see first how to start. So first of all, make a diagram for given data. So it is given magnetic field. It is given uniform steady magnetic field in between x equal to 0 and x equal to L. Let us take this is x-axis. Now given field is from x equal to 0 to, suppose this is now origin, x equal to 0, and this is now x equal to L. Now magnetic field is present in this region. Let us consider this is x and this is y. Okay. That means k cap is now outwards, means normal to the boat. It is towards us, k cap. And field given, magnetic field, B bar equal to, it is B naught minus k cap. Okay. That means it is now into the boat. That means normal to boat. It is inwards. Okay. And given particle of mass m, charge q, charge is positive, velocity v naught I cap. Velocity v bar equal to, it is v naught I cap. Enters the region of magnetic field. And here we have to neglect gravity. Coming to the first part, condition given. Final velocity at an angle 30 degrees to its initial velocity. Now see carefully. It enters at origin, right? That is cross-checked once along, enters into region of magnetic field. Okay. It enters now. Right. It enters into magnetic field. First of all, focus in which direction force is acting. So I am writing here F bar equal to Q into V bar cross V bar. Charge given positive. Velocity, direction I cap. I cap. So I cap, I am focusing only direction part. I cap across direction of field minus K cap. So I cap across minus K cap. So you are knowing that I cap, J cap, K cap. K cap across I cap, that is J cap. I cap across K cap, that is minus J cap. and minus of minus plus. It is now j cap. So direction of force, it is along positive y-axis. That means if it enters here, okay, it follows now path like this. It is now circular path. The reason is that velocity is in xy plane. It is along x-axis and field is normal to this plane. So between V bar and B bar, angle is 90. So when angle is 90, it follows circular path. That means now this will be a part of a circle. Okay, from here to up to here. Now condition given that this is now part of circle. So condition is given that its velocity vector makes angle 30 with initial velocity. This is now final velocity that makes angle 30 with initial velocity. Okay. So now what we have to find here, L value how much. Now here what I am doing, draw normal for this velocity vector. Okay. So I'm taking here normal for that velocity vector. So this line is nothing but normal for that velocity vector. Next, draw normal to velocity vector at this point. Okay. I'm taking normal to that velocity at that point. So point of intersection of these normals will be center of that circle. Okay. This is now center for the circle, center C. And you can see this is angle 30, then this also 30. See carefully, this line is normal to this velocity and this line is normal to x-axis. So between the normals is same angle, okay, 30. That means if you extend now this line, this length equal to L, right? And given angle is now 30. So when angle is a 30, right? This is now L. And this length will be, it is equal to radius, right? That means sine 30, that is 1 by 2. Sine 30, that is equal to L by R, opposite by hypotenuse. Sine 30 means 1 by 2. That means L equal to R by 2. And we are knowing that radius is equal to mv by bq. V means here V naught, B means B naught, mv by bq. Okay, R value is known. That means now L value is known. Okay, right. Now see second part in this one. Find the final velocity of the particle and the time spent by it in magnetic field. If magnetic field now expands up to 2.1 L, now see carefully, up to 2.1 L. See where change comes. It is a magnetic field is now from x equal to 0. Now in this case, it is up to x equal to 2.1 L. Okay. And we got L value how much? R by 2. Then see what is the value of 2.1 L? Okay. This is equal to 2.1 into, in the place of L, I am writing R by 2. Okay. Then see how much we get. So this value 2.1 by 2, right? That means it is now greater than R. We have to focus that this value 2.1 by 2 into R So this value is greater than 1. Okay. That means this length 0 to 2.1 L, 2.1 L, this is now greater than R. Okay. In such a case, particle is able to complete half circle. It enters like this. It completes now half circle, completes half circle and comes outside the field like this. That means velocity will be final velocity vector is equal to minus v naught I cap. No change in speed, right? The only change is now direction part. It is opposite. That's why I have taken here minus. Okay. And see how much time it has spent inside. Okay. It is now completing half revolution, right? That means time taken or time spent, that is equal to pi into m by bq. So we have learned that time period of revolution equal to 2 pi into m by bq. It is now half revolution. That's why pi into m by bq. Okay. Let us see the next one. Let's see the question given. A rectangular loop PQRS made from a uniform wire has length A, width B, and mass M. It is free to rotate about the arm PQ, which remains hinged along a horizontal line taken as the y-axis as shown. Take the vertically upward direction as z-axis. A uniform magnetic field B bar equal to 3 I cap plus 4 K cap B naught exists in the region. The loop is held in the xy plane and a current I is passed through it. The loop is now released and, and is found to stay in the horizontal position in equilibrium. See diagram here. PQRS. Okay. What is direction of current in PQ? Okay. Find the magnetic force on the arm RS. Find expressions for I in terms of B naught, A, B, and M. Okay. So first see the question given and see how to start. Right. First of all, make a diagram. Make the given diagram. It is given Y. This is Y. And this is given as z axis. And outwards means towards us, that is now x axis. Right now, taking one rectangular loop. Loop is given, shape is rectangle. So it is now two sides are parallel to x axis. And remain two sides are parallel to y axis. You can see in diagram. PQ, this is now hinged. PQ, R, S, and this length is now A. And this is now B. Right. Now, first of all, What is direction of current in PQ? Means is the current is like this or current is like this. That means when we see from top, if current is like this, it is a clockwise when we see from top. Okay. So is it a clockwise or anti-clockwise? First of all, focus the condition given. It is given the loop is now released and is found to stay in horizontal position in equilibrium. This loop is not rotating. Okay, that condition is given. That means on this loop, net torque equal to 0. And condition given that PQ, the loop is now hinged about PQ. Therefore, we have to take net torque about PQ should be 0. Okay. Now see carefully what the equations we have tried here. Net torque condition, net torque equal to 0. So writing here torque about PQ should be 0 condition. Torque about PQ should be 0. And see here one more thing, it is given magnetic field. See B bar equal to B naught into 3I cap plus 4K cap. This is now field given, right? And you can see because of the current here, this loop acts as a magnet, right? In such a case, it is having magnetic dipole moment. And once we're having here magnetic field, because of the torque acts on the loop. Okay. So first of all, there is a torque because of gravity. So I'm writing here torque due to gravity. Torque due to gravity plus torque due to magnetic force, or you can say magnetic field, sum equal to 0. Now see carefully. Because of gravitational force, torque will be because of gravitational force torque. mg, it is vertical downwards. That means according to diagram, mg will be along negative z axis. Okay. xy is a horizontal plane. Z is now upwards and mg is now downwards. So mg into perpendicular distance, that is equal to a by 2, right? It is equal to a by 2. And see now direction for this torque. Rotation will be about to PQ. So torque will be now direction is it is J cap. See how we got J cap carefully. If you want to write in vector form, I can write here mg into minus k cap. So I'll write here once. It is mg into minus k cap. Okay. Torque is now R bar cross F bar. Let me erase this. Torque is R bar cross. Torque is R bar. R bar, as you can see, A by 2 into I cap. See carefully, this is a parallel to x-axis. So A by 2, R bar, A by 2 I cap, R bar cross F bar. F bar is mg into minus k cap. Okay. See what we get here. I cap cross minus k cap. I cap cross k cap. That is minus j cap. Minus of minus plus. That's what is j cap. Okay. Now, since net torque equal to 0, torque due to a magnetic field should be along negative y-axis. Okay. Then see here what I am doing. Torque due to a magnetic field, that is m bar cross b bar. Right. Direction of m bar. So right now that we are not knowing. Okay. So what I'm doing here, first of all, I'm focused here. What is modulus value? So we are knowing m bar equal to I into n into a bar, right? So first I'm focusing the direction part, sorry, only modulus value. So it is I into, we are taking number of turns. It is 1, area equal to A into B. Okay. Direction part that we have to decide. Okay. Cross B bar, B naught into 3I cap plus 4K cap. Okay. So here what happens is direction must be minus J cap. So only in that case, sum of those two vectors equal to 0 bar. Okay. Now here something is there, something cross I cap. Okay. So one thing we can guess here, current is either clockwise when we see from top, either clockwise. If it is a clockwise, curl fingers of right hand. Okay. Curl fingers of right hand along the current flow. Means curl fingers clockwise. Then M bar will be along negative z direction, means minus K cap. Okay. If you are taking clockwise. If you are taking it is anti-clockwise. If you take anti-clockwise, curl fingers of your right hand anti-clockwise. Thumb will be upwards, means it is a K cap. That means in this place we should write either plus K cap or minus K cap. So that finally we have to get direction minus J cap. Okay. That means if I am taking here either plus K cap or minus K cap, if you take cross with this K cap, that will be 0, right? Remaining is only I cap and this one. So K cap cross I cap. K cap cross I cap is J cap, right? But we should get minus J cap. That means this must be minus K cap. Okay. So I'm writing here minus K cap. Then minus K cap cross I cap. That will be minus J cap. So it is now I, A, B, B naught, and 3 is there. It is now minus J cap. That means here we should take minus K cap. Minus K cap means direction of current must be clockwise when we see from top. That means current flows from P to Q. Okay. Current flows from P to Q. So P to Q means it is now like this. Okay. In this field. That is now current. Right. And see next what we have to calculate. Loop is now released and found to stay in horizontal position in equilibrium. Right. So here, what is direction of current I in PQ that we got from P to Q? Second, find magnetic force on the arm RS. Right. Magnetic force F bar is equal to I into L bar cross B bar. L means length of PQ, that is B. Okay. So B into direction of current. It is along positive y-axis, right? Along positive y-axis. Wait, it is a positive y, negative y. It is asking force on which side? Force on RS, right? Right, right. RS means it is along negative y-axis. Okay. So negative y-axis means it is minus J cap. Force acting on RS. Right. So I into L bar. It is a B into direction minus J cap. L bar cross B bar. B bar is now. It is B naught into 3I cap plus 4K cap. Okay. Now see what we get here. I think first of all, we have to focus. He's asking what is the current, right? What is direction of current in PQ? Okay. Right. For example, see here what we get I into. I am taking B outside, B not outside. Remaining is now minus J cap across I cap. Then see what we get here. It is I, B, B naught. We have taken outside. Remaining is now 3 minus J cap across I cap. It is minus K cap, minus of minus plus 3 K cap. Okay. And next minus J cap across K cap. That is I cap. So 4 I cap. Okay. Next, focus here. Find expression for I in terms of given quantities. Expression for I means what we can do is condition sum of the torques equal to 0. That means we can equate now those torques, their modulus values. So here mg into a by 2, that is equal to, so here torque is now I a b naught into 3. Okay. From this, see what is the current. From this current, I equal to, so what we can cancel here, a gets cancelled, mg by 2 remaining. Okay. So I equal to mg upon 3 to 6, 6 small b and b naught. This is now current. If you want to force, okay, we can take now this I value in this one. Okay. Then we are going to get now force in terms of given quantities, right? And see what else left in that. We got direction of force. That is first one, P to Q. Magnetic force on RS that we got. Here I have to substitute in the place of I this value. And last one, expression for I in terms of B naught. In terms of B naught, B and mg, right? So I hope you got a clarity.